Now here we do another type of question based on switching circuit, that is simplify the following circuit so that it has fewer number of switches than the original. So we are given a circuit in which there are a lot of switches, some are in negation state also. So the meaning of the question is that the operation of the circuit is to be retained but with the fewer number of switches. So we have to make use of the laws in the logic, and we will see how we can have another simpler and smaller circuit which behaves exactly same as the given circuit but with fewer switches. So alright, now here as we have done earlier, let us indicate S1 as P and S2 as Q. So therefore clearly S1 dash will be nothing but negation P and S2 dash will be negation Q. So let us indicate the respective symbols. Alright, now if the lamp state is denoted by L, then as per the diagram shown, as per the circuit, you see that it consists of 3 branches in parallel. So on highest level it is the parallel connection, that means it is the OR operation of 3 smaller operations, 3 smaller statement pattern. Now in the uppermost branch we have the series connection, that means it is having the AND operation. So therefore we fill the respective places. The first branch is P and negation Q, second branch will be negation P and Q, and the third branch will be negation P and negation Q. Okay. Now we have to simplify this. For this let us observe what we have got. If you observe from the first 2 brackets, there is nothing that can be taken common. All the terms are exactly opposites of each other. So therefore if we turn our attention to the second and third, you'll observe that negation P can be taken common from both of the brackets. So it's like we are applying the reverse of the distributive law, right? So first bracket remains as it is, that is P and negation Q, or now from the remaining 2 we take negation P common, and inside what remains is Q and negation Q. So therefore it will be Q or negation Q. So moving on, P and negation Q as it is, or we have negation P and now let us look at the expression Q or negation Q. We have seen earlier that Q or negation Q represent 2 opposite states. So one of them has to be true, the other one has to be false. So when one is true, the OR is always true. So that gives us straight away true. Okay, now if we look at the second bracket, you see there is an AND operation and one of the input is true. So clearly as per the laws, the result will be same as the other unknown input. So that will be equal to negation P. Now here we use the distributive law to open the bracket. So therefore we distribute the negation P to the elements inside the bracket. So we have P or negation P and negation Q or negation P. Lastly we have P or negation P. Once again it is true because there is an OR operation of the opposite truth values. And in the second bracket let us make a minor change, that is let us use the commutative law to write it as negation P or negation Q. And lastly in the AND we have one input as true, so therefore the result will follow the other input. So therefore we have finally negation P or negation Q. So you see we have finally got just two symbols in the equivalent statement, and that is nothing but negation P or negation Q. So since it's an OR, clearly it means it's a parallel branching of 2 switches. Negation P and negation Q means it is S1 dash and S2 dash, and these 2 switches are connected in parallel with a battery and a lamp. So you see that the operation of this circuit so obtained is exactly same as operation of the original circuit. So you see, in the original circuit there were 6 switches, but we can have just 2 switches and achieve the same operation. So that is what is the meaning of circuit simplification with the help of laws in mathematical logic.